Lastly, if you find out the value of escape velocity for Earth, in this equation you put the value of g and put the value of r as 6400 kilometers, what will you get? Solve it right now. You will get escape velocity is equal to 11.2 kilometers per second. So 11.2 kilometer per second is the minimum velocity which is required by all the projectiles which are projected in space from Earth, and that is the minimum velocity. So you can very well imagine that if we have a limit that is called minimum velocity, we do not use that limit, right? We project the particles or objects at velocities way beyond this minimum value. That is how we overcome the value of overcome the possibility of any failure, right? The last topic in this unit would be weightlessness. Now, what is weightlessness? See, suppose right now I am standing on that weight measuring scale or that meter or whatever you call it, that is called weight measuring device, right? So right now suppose I am standing up here on the weight measuring device. Okay, take this example. All of you guys have seen the swimming pool, right? The water inside it, but don't go there. It's like this platform from where the athletes actually jump on the swimming pool, right? This is that wooden bar from which they stand and they flip and they do all sort of aerobatics. Now, at this point, this person is standing on a weight measuring scale which is showing its weight. I am taking two examples. Also, an example of lift in which we have few people or one person who's standing on again a weight measuring scale, right? Now, right now the machine would be giving the reading of 80 kg or 70 kg, whatever the weight of the body is, right? Suppose someone actually cuts this wood or someone cuts this rope, what will happen? This person and this person both will fall, which is called free fall, right? This is called free fall. Now, at this point, they are still standing on the weight measuring device. What do you think the reading in that would be? How do machine gives the reading? To answer that question, first ask yourself, how do that machine gives the reading? If I am elevating myself up, I am feeling a bit uncomfortable or unbalanced. That is because the gravitational force is pulling me down. So that force, which is called weight, which is product of mass and gravity, that has been exerted on me on the downward side, due to which there is a pressure on the weighing scale, and hence scale shows you the reading or the calculation. But at this point, there is no such force which is acting on from the up towards down on the machine, because both the body and machine are falling from the same acceleration. There is no relative motion, and that is why the weighing machine at this point will be showing the value 0. This is called weightlessness. So I have explained you this term in very different way. So weightlessness basically means in physics is when a body does a free fall means it is falling freely because of gravity. The weight of the body is 0, and for a moment it feels like it is weightless. That is called weightlessness, and this is due to apparent, this whole fact or phenomena is due to apparent weight of the body. And what is apparent weight? See, first of all, we have done it in laws of motion, but we'll do it again. First of all, consider the lift. Weight of the body here would be mg. If the body is accelerating upwards with acceleration a, then weight will be mg plus a. Lastly, when the lift is going downwards with acceleration a, apparent weight would be m times g minus a. So during free fall, what is the acceleration with which bodies fall? This is g. So g minus g, which is 0, and that is why net weight comes out to be 0. So this is all you need to know about weightlessness.